Hello students, welcome to a class of matrices. I'm Swan Vincent, a tutor of mathematics and science courses. I'd like to take you through matrices and that is types of matrices in particular before we move on to, of course, a class of operation on matrices. And in concern, these are also a course that is offered in most of the universities, so it is good for a student to have a concept. This concept of matrices, it is also offered in by a course by the name quantitative skills in most of the universities. Then when you talk of matrices in particular, matrices is the plural part of the word, but we've got now the singular part, which is the matrix. So a matrix is a regular arrangement of numbers or figures in form of rows and columns. So after noting this, then it is also important that you now move and understand the types of matrices. So type of the matrices, which is number one, I've highlighted column matrix. A column matrix, these are kind of a matrix that has one column and multiple rows. So it has got a single column. That's why it is being referred to as a column matrix. As you can see on the slide, I've provided the example. That is, and something before I forget, something also that I would like to praise on to ensure that you understand, to place some emphasis on it, is that a matrix is a specific kind of mathematics whereby it has got its name, whereby you can see I've placed A, that's the alphabetic, whereby I've equated again to a matrix whereby there is the brackets. So these are the specific characteristics of a matrix. A matrix should have its name, that is the alphabet. Then from there we've got the parentheses, that is the brackets. The brackets should also be included. Then from there we move to the row matrix. When you talk of the row matrix, this is another type of a matrix whereby these are kind of a matrix that has one row and several columns. We've got several columns. As you can see to that example that I've provided, it is only one row, but you see 4 alone, it is a column on its own, 5 column on its own, 6 column on its own, 7 a column on its own. So we refer to it as a row matrix because it has only one row, Then column, we said it's also being referred to as column because it has a singular column. Point taken. Then we move to, that is another example, that is the square matrix. This when you talk of a square matrix, these are type of matrix whereby the number of rows equates to the number of columns. As you can see from the example I've provided, when you try to count or compare the number of rows and the number of columns, you'll see that they are equating. We've got 3 number of rows and 3 number of columns. Such a kind of a matrix, we refer to it as a square matrix. Then type number 4 that I've also highlighted is the diagonal matrix. These are kind of a matrix that has 0 everywhere except on the main or else the major diagonal where there is scalars. Now check on this. On the matrix there is normally diagonals, and we've got the major diagonal and the minor diagonal. The major diagonal can also be referred to as the leading diagonal, and the minor diagonal, it is the one that runs all the way from the upper right hand side to the lower left hand side, while the major diagonal runs from the upper left hand side to the lower right hand side. So that kind of a matrix, so the diagonal matrix, these are kind of matrix that have 0 everywhere, but there is the scalars or the numbers or the figures, they are in particular arranged, that is on the major or leading diagonal. Then from there we move to the next kind of matrix, that is the identity matrix. These are square matrix with the leading diagonal elements equal to 1 and all the other elements equal to 0. So when you try to check also at this, we are still considering the factor of the diagonals in a matrix, whereby we are saying in an identity matrix, the leading diagonal or the major diagonal has got its element being represented as 1 1 1 1. That is the number 1. Then the other parts of the matrix, they are occupied by zeros. So that kind of a matrix, we refer to it as an identity matrix. Then we move on to the zero matrix, or it can also be referred to as null matrix. These are kind of a matrix whereby every element in a square matrix is equal to 0. So first thing you need to note that a zero matrix is a square matrix whereby the rows and the columns should equate. Then from there, if at all the rows and the columns are equating, then the elements in it are 0. Of course, the figures in the matrix, in the bracket that is, they are referred to as elements. And therefore, after knowing that, there is some properties I would like us to note under the zero or null matrix. So under this kind of a matrix, it has got two main properties that it operates under. That is, when a null matrix is added to or subtracted from another matrix, the matrix remains unchanged. That is, when you subtract, that is, let's say we've got matrix A with the 3 4 as first row, 4 5 as second row in bracket, then you subtract or add, that is, you place the positive sign or you place the negative sign to show the addition or the subtraction kind of operation. Then when you try to do that kind of operation, you'll find that it will end up not changing, because the matrix will remain unchanged. But when you have the same kind of matrix, that is A is equals to 3 4 then 4 5 being multiplied by now, or that is, you can pre, it means before, then post, it means after placing. That is, you either place the null matrix after or before the matrix A, which is 3 4 4 5. When you try to multiply, you'll find there will be change, because the elements will now turn to 0. So you'll find the new matrix will be also a null matrix. That's why we are saying pre or post multiplying a matrix with a null matrix results in another matrix, while when you do the addition or the subtraction, it results to no change. Then from there, lastly, I would like us also to consider these the two kinds of the matrix, that is number 7 and number 8. We've got the scalar matrix. This is a diagonal matrix whose diagonal elements are equal. Remember, we said the square matrix, this is where the rows and the columns equate. But when you talk of the scalar matrix, this is now a kind of a scalar matrix. Okay, a kind of a matrix, I mean, whereby the elements on the diagonals are equal. So when you try to check on the major diagonal or the leading diagonal, we've got 10 10. On the minor diagonal, we've got 0 0. So you see, the elements are equal. And this kind of a matrix, we refer to it as a scalar matrix. Then from there we move to triangular matrix, which is the last one. This is a special type of a square matrix where all the values above or below the diagonal are 0. So with this kind of a matrix, it has got mainly two types. We got the upper triangular matrix and the lower triangular matrix, like the one I've provided or I've availed on the screen. This one is a kind of a matrix that we refer to as upper triangular matrix, whereby you see the zeros are below the major diagonal. The major diagonal, if you at all, you can identify it as got, that is from the upper left we've got 3, and from the lower right we've got 1. So that is the kind of the major diagonal, and below it we've got zeros. So that kind of a diagonal of a triangular matrix, I mean, is referred to as upper triangular matrix. And what if the zeros were above now the leading diagonal? You will now refer to that as a lower triangular matrix. Let me hope you've enjoyed the class, and I would like you people to subscribe, share, and also you can hit the notification in that you access to more of my videos, to more of my tutorials, whereby I'm teaching mathematics and I'm also giving out direction on science courses in particular. Have a nice day. Enjoy yourself.